This is a Prezi that I've made to help you out with our first topic called number systems. So first, I want to ask you what a number is. And think about this. What is a number? What do we know as a number? And how did you first learn about numbers? Well, usually when you first learn about numbers, you count. And you learn how to count just 1, 2, 3, 4. So through counting, you learned what is called natural numbers or counting numbers. So this is one category of numbers in itself. So numbers 1, 2, 3, 4, all the way to how much you can count. And the symbol that we're going to use for these types of numbers is called just n. So that's our first category of numbers. But aren't there other numbers that exist? For example, we haven't talked about 0 yet, because when we learn to count, we don't go 0, 1, 2. We usually just go 1, 2, 3, 4. Attach that 0 to the natural numbers, and we call these whole numbers. So 0, 1, 2, 3, 4. These are whole numbers. So whole numbers are natural numbers, but with a 0. So we're going to use the same symbol as we did in the last slide, n, but we're just going to add a little 0 on the bottom there. So yeah, it's possible that some numbers can have two different categories. For example, 1 is a whole number, but it's also a natural number. And there are also negative numbers that we need to think about, like -2, -1. And when we attach those negative numbers, no decimals yet, if we attach those negative numbers to our whole or natural numbers, we call all of these integers. And we call integers z. Sometimes you'll see it as I, don't worry, I and z are the same symbol for integers. So again, this number 1 here, so far we've called it a whole number, a natural number, and an integer. And that's fine. Some numbers can have many different categories. But now we're just adding negative numbers. So for example, -2, right now, we know it as an integer. And this goes all the way, -2, -3, -4, all the way to the biggest negative you can count. So as I was saying, many different numbers can have several definitions, don't worry. And I'm going to add even more to that right now. For example, here are some numbers that we haven't really seen yet, but these are numbers, right? Your 7.6590 continuing, your 8.5, your 7.22222 repeating, 2.8, etc. And where do these fit in? Because these are not whole, natural, or integers, because we haven't seen decimals yet. Where do they come from is the first question that I would like to ask you. Some people think that decimals come from a fraction, and that's true, right? If you divide the top, the numerator, by the bottom, we get decimals. And in this case, fractions, we never really see decimals in fractions. Fractions are usually like whole numbers, okay? And we divide the top by the bottom when the 0 is not in the denominator, because it's impossible to divide anything by 0. These fractions form decimals that in the end they eventually repeat in some kind of pattern, right? It doesn't matter if you have a whole over a whole, in the end they will eventually repeat. So 1/2 is 0.5, 1 over 3 is 0.33. But if you have a big number like this, I'm telling you that it will eventually repeat. So whole over whole will give you a repeating decimal. These are called rational numbers. We assign the letter Q to these types of numbers. And again, these are numbers that either decimals eventually stop or repeat. So fractions are rational numbers. Decimals that stop or repeat are rational numbers. Let's talk about 8 over 1. Isn't 8 over 1 a fraction? Every whole or natural number is over 1. And every -2 over 1, that is also a fraction. These are rational numbers too. If we can put anything under a fraction, whether it's 1 over 2 or 2 over 1 or -2 over 1, these are rational numbers too. Again, lots of different categories, okay? But the more we look at them and the more we practice them, the more you'll be able to easily identify them. Are there any decimal numbers that ever don't repeat or stop? Yes. Let's take a look at some. I have the square root of 2 is 1.4142135. That actually never repeats. And pi is the most common decimal number that never, ever, ever repeats. Typically, the root of a number isn't an exact number. If it isn't an exact number, it's a decimal that never repeats. So if you had the square root of 4, it's 2. But if you have any root of a number that is not a whole number, it will always repeat. In this case, decimal numbers that don't repeat and cannot be put into a fraction, these are called irrational numbers. And so we use the same symbol that we use for rational, except we use a little apostrophe. We'll call this Q prime, okay? Or if you want Q apostrophe, but Q prime is usually the symbol used for irrational numbers, decimals that never repeat and cannot be put into a fraction. Okay, so I've given you a lot, but we're not quite done yet. There's one more thing that you need to understand. Together, rational and irrational numbers are called the set of real numbers. Every single number is under the set of real number. Whether they're negative, positive, decimal, or not, everything is part of a set of real numbers. Okay? So, to recap, you have real numbers, and in real numbers, you have two categories, rational and irrational numbers. Rational numbers can either be integers, and those integers can be natural or whole numbers. Okay, so this is essentially your big flow chart. Everything is a real number. Is it rational or irrational? If it's irrational, you're done. If it's rational, well, can it be an integer? Yeah. If it's an integer, is it a natural number or not? So negative numbers are not natural numbers. Okay, so that's your chart, okay, to keep in mind. Before we move on, though, just going back, everything is a real number except imaginary numbers, okay? Imaginary numbers are the square root of negative numbers. You cannot have the square root of a negative number, okay? Those are imaginary numbers, and so they are not anything. They're not real, they're not rational, irrational, integer. The square root of a negative number is not a real number. The square root of a negative number is an imaginary number. All right, so now, what is the purpose of all these definitions? Okay, I'm sure that's a good question. As we continue the year and as you continue in your math careers, your teacher, any teacher, will refer to certain kinds of numbers for different important reasons. So it's important that you know what numbers I'm talking about. So if I'm telling you it's just the integers, you need to know that I'm only talking about the negatives and the positive whole numbers, okay? At this point, now that you know everything, it's very important that you practice classifying them. And so now that you know everything, it's your turn to try classifying a whole bunch of different numbers based on the number systems that I have given you in this lesson.